Hello and welcome once again on the lecture series of course Elements of Machine Design. Today we are in the lecture number 15 and in the last bit of first chapter, that is the stress concentration. In the last lecture we have studied the ergonomical considerations in designing a machine element. We have seen what is meant by the ergonomics, what are the ergonomical considerations regarding the displays, what are the ergonomical considerations regarding the controls and man-machine relationship. So today we are in the lecture number 15. Today we will see the concept of stress concentration. Now, before going into the concept of stress concentration, let's see what is meant by the concentration. Now, stress concentration, it is defined as the localization of high stresses. The first part in the stress concentration, concept of stress concentration, we have already studied the concept of stress. Now, in the concept of stress, we have seen that it is the internal resistance offered by the element to the application of force. Means it is the force per unit internal resistance, force per unit area. Now, due to the application of load, there is an induction of stress. But in some point, in some manners, in some application, there is a possibility of the stress concentration. Now, as we have defined, it is the localization of high stresses. Now, what is the reason behind this localization of high stresses? Due to irregularities present in the component and abrupt changes of cross-section. Now, these are the two important causes due to which there is a possibility of a stress concentration, means localization of a high stress at a particular point, induction of a large intensity of stress at a particular point. That is the localization of the high stresses. And the reason behind this is the irregularities present in the component and sudden changes of the cross section, because this internal resisting area which actually resisting the applied force. Now let's see the example of this plate. Now a plate with a small circular hole subjected to the tensile stress. Now this plate is subjected to the tensile stress as the force is pulling this component. When there is a tensile force is applied on this component, there is one hole at the center of the plate. If you want to understand the concept of stress concentration, the localized stresses will develop at the vicinity of this plate here at this cross section. In this cross section, there is a possibility of the breaking of this plate because the maximum stress concentration will develop in this area. This is the development of the maximum stress concentration. In this area, there is a development of the maximum stress concentration. Why? Because there is a presence of hole at the center of this plate. And due to the presence of hole, there is a irregularities in the section. And due to these irregularities, there is a chances of localization of this high stress. Now this is known as the stress concentration. Understand? Now let's move towards the causes of stress concentration. What are the causes of stress concentration? The first cause is the variation in the properties of materials. Now, in design of machine element, it is assumed that the material is homogeneous throughout the component. Now, it is one of the main assumptions when we are considering a particular material, when we are considering a particular component, when we are designing a particular component, and when we select a particular material for designing of that component, we are considering that the material is homogeneous, means it has the same properties throughout the all sections, the physical properties, its thermal properties, as well as its chemical properties. So we are considering that the material is homogeneous. But in practice, there is a variation in material properties from one end to the another end due to the following factors. Now, which factors which cause the stress concentration? Internal cracks and flaws like blowholes. If there is a presence of internal cracks in the material and flaws like blowholes, which occurs at the time of the manufacturing processes, which occurs at the time of the heat treatment processes, which occurs at the time of the casting. Now these blowholes and internal cracks causes the stress concentration, which causes the change in property of the material. Cavity in welds. While welding a particular component, while performing a welding operation, there is a chances of formation of cavities during the welding operation. Air holes in the steel component, non-metallic or foreign inclusions. Now these all cause the heterogeneous of the component. These all factors contribute towards the variation in properties of the material. And due to the variation in the properties of the material, there is a chances of stress concentration. Now second chance is the load application. The second cause of stress concentration is the application of load. Now we know that when machine components are subjected to the forces, mean loads, during the application. Now these forces act either at a point or over a small area of the component. Now there is an uneven distribution, non-linear distribution of these forces along the component. Due to the non-uniformity of load distribution, there is a chances of causing a localized stress at a particular point. The example of load application are the contact between the meshing teeth of driving and driven gear. When the two gears mesh with each other at a particular point, there is a chances of at a single point there is a large load and at another point there is a small load. Now these variations will cause the localization of the stress concentration. That is the contact between the meshing teeth of the driving and driven gear. This is the another cause, that is the application of uneven load. First cause is the variation in the properties of the materials. Another example of uneven distribution of force is the contact between the cam and follower. When there is a contact between cam and follower, at certain point there will be a more load will be applied on the cam. At some point there will be less load will be applied between the cam. Same examples are there: contact between the balls and races of the ball bearing, contact between the rail and the wheel, contact between the crane hook and the chain. These are the simple examples where the load distribution is not uniform. In all these cases, the concentrated load is applied over a very small area, which results in stress concentration. In simple language, when there is an uneven distribution of load among the component, there is a chances of localization of stresses at a particular point, which adds towards the stress concentration effect. Now third reason due to which there is a possibility of stress concentration is the abrupt change in section. Abrupt means sudden changes in sections. We know that in order to mount gears, sprocket, pulleys and ball bearings on a transmission shaft, the transmission shaft means the shaft which is used for the transmission of power. Now steps are cut on the shaft and shoulders are provided from assembly considerations. Now these are the steps. This area is the step area. Now for the mountings of these, some keyways are cut here for the accommodation of key. the keyways are cut on the shaft for the accommodation of key. For this mounting of these gears, sprockets and pulleys, some step formation is there. Now this is the step formation. Now this is one part, there is a change in cross section. Now there is a step formation. Due to this step formation, there is a chances of localization of the stresses. Now these features are essential. They create change of cross section of the shaft. This results in stress concentration at this cross section. Now here will be the resultant stress will be there. At this section there will be a possibility of the stress concentration. Now at these sections there will be a possibility of this stress concentration due to the changes in the cross section of the component. Means there is a change in the surface area of the component, there is a change in the shape of the component, due to which there is a possibility of formation of stress concentration or a localization of stress concentration at a particular point. Now next cause is the discontinuities in the component. Discontinuities in the component. Now certain features of machine component such as oil holes or oil grooves, keyways which are adapted for the keys, and splines and screw threads results in discontinuities in the cross section of the component. Discontinuities in the component means the cross section of the component is not continue. There is a possibility of keyways in the component. There is a possibility of the holes in the component which will cause localization of a stress at that hole point, that will cause localization of the stress at that keyway point. Now this component is discontinuous. There is a keyway slot is provided in the shaft. Now this component is not the continuous component. That is the discontinuity in the component which cause the stress concentration at that particular point. Fifth point is the machining scratches. Machining scratches, stamp marks or inspection marks are surface irregularities which causes stress concentration. We know that on many component we are providing some kind of a stamp for the identification of the element, for the identification of the component. Sometimes we are scratching for the marking purpose that component. Now these surface irregularities will add towards the localization of the stresses, which is nothing but the stress concentration. So we have seen the meaning of stress concentration, that is the localization of the stresses, high stresses at a particular point. Now what is the main reason? Irregularities present in the component and sudden changes of the cross section. The possible causes are variation in the properties of the material due to the different load applications, abrupt changes in the section, discontinuities in the component, and machining scratches. Now what are the methods to reduce the stress concentration? The first method is providing additional notches and holes in tension member. Now we have seen what are the causes of the stress concentration. Now we have to see how we can reduce the stress concentration. We can't eliminate the 100% stress concentration, but we can reduce the intensity of localization of the stresses. That is nothing but the reduction of stress concentration. Now what are the ways how we can reduce that stress concentration, that we have to see. Now if it is a tension member, if that component is subjected to the application of tensile force, then how we can reduce the stress concentration in the component which is subjected to the tensile loading. Now in this case, this is the component. Look at this component. Now this is the component which is subjected to the tensile loading. Now how we can reduce the stress concentration when these components are subjected to the tensile loading? The first is now this is the original notch. Reduction of stress concentration due to V notch. Now what we have seen, the methods are providing a holes or providing a additional notches or drilling additional notches and removal of undesired material. Use of multiple notches. Look at this. Now this is the plate. Now this is the plate with original notch. This is the notch. This is known as the notch in a plate. Now this is the original notch. This is the plate, original plate with the V notch. One notch is here and one notch is here. Now due to this notch present in this place, there is a possibility of stress concentration at this area. There is a possibility of stress concentration at this area. Look at this streamline. If you look at the streamline, there is a possibility of gathering or localization of high stresses at a particular point. Means at this point there is a possibility of the stress concentration. At this point there is a possibility of the stress concentration in this member. Now we have to reduce this stress concentration. Means the stress which is concentrated at a particular point, we have to separate that stress, we have to distribute that stress concentration. Even distribution should be there. For this we are provided multiple notches. Now in this component there is only one notch, and due to the presence of this one notch, now this notch will act as a discontinuity in the component. We have seen the cause of the stress concentration, that is the discontinuity in the component. Now this notch will act as the discontinuous member in the component. Due to this there is a possibility of the stress concentration. Now we have to reduce this stress concentration. How we can reduce? By providing a multiple notches. If we provide the multiple notches, look at this force line. We can see the force line is evenly distributed. In this case the force line is suddenly curved. There is a possibility of the localization of stress at this point, but in this case the stress is evenly distributed among these notches. So there is a less chance of stress concentration. That is, the intensity will get reduced. There is a stress concentration, but the intensity will get reduced due to this. Second is the provision of holes. Now this is the original component, original notch. The first method of reducing stress concentration is the providing multiple notches. We are looking this all the parameters for the tensile member when the member is subjected to the tensile force or tensile loading or tensile stress. First method is the providing the multiple notches. Second method is the providing the different holes, number of holes around this notch. And third method is removal of undesired material. Now this is the undesired material. If we remove this undesired material from this cross section, there is a possibility of the even distribution of this force line. Means the stress concentration will get reduced due to the removal of unwanted materials. Now for the tensile members, the method of reduction of stress concentration is first providing multiple notches, second providing holes, and third removal of undesired material. Now this is for tensile member. In these three methods, the sharp bending of force flow line is reduced and it follows a smooth curve. Now second method is for the member in bending. Now we have seen for the component in tensile, we are looking at the component in bending. Now this is the component which is subjected to the bending moment. These are the bending moment, sign of the bending moment. Now this is the discontinuity in this member, in this part. There is a sudden change in the cross section of the component. Due to the sudden change in the cross section, there is a possibility of the stress concentration at this point. There is a possibility of the stress concentration at the point, means at the corners. Due to the sudden change in the cross section of the component, there is a chance of stress concentration at these corners. Look at this stream flow line. This is the force line. It is suddenly changing its line. So there is a possibility of stress concentration at this point. Now how we can reduce this stress concentration? First method is fillet radius. By providing this fillet radius, means we are provided a fillet of a certain radius, say R, at the corner. In this case there is a sharp corner of 90 degree. Now in this case we are provided a In this case, we are provided a fillet radius, due to which the streamline will follow a smooth path. In this case, there is a sudden change in streamline, but in this case, there is a smooth pattern of streamline, due to which the intensity of the stress concentration, always keep in mind, there is no 100% reduction of the stress concentration, but the intensity of the stress concentration will get reduced due to this. So the first method to reduce the stress concentration when the member is subjected to bending is providing a fillet radius. Second is undercutting. Here is the undercutting. Due to the provision of undercutting in this part, there is a possibility of reduction of stress concentration. Look at this. A bar of a circular cross section with a shoulder subjected to bending moment is shown in diagram A. This is the bar. Now ball bearing and gears or pulleys are sealed against the shoulder. Now on this part, there is a pulleys are mounted, gears are mounted, and the shoulder creates a change in cross section of the shaft, which results in the cross section. This is the shoulder. Now first method is the providing fillet radius, second method is the providing undercut, and third method is the providing additional notch on the component. After providing a fillet, here we have provided the fillet. After providing a fillet, additional notch is provided, which again reduces the possibility of the stress concentration. So the three methods to reduce the stress concentration in member which is subjected to bending are: first, providing a fillet radius, second, providing a undercut, and third, providing a additional notch. This is for the members in bending. Now third method of reduction of stress concentration is the drilling additional holes for shaft. Now when shaft, there is a possibility of the stress concentration in a shaft due to the provision of keyway. In this case, look at this shaft. A transmission shaft with a keyway is shown in figure. This is the shaft which is provided with a keyway. This portion is known as the keyway because there is a insertion of key having width W and height H. This is the portion which is provided for the insertion of key on the shaft. That portion, that space is known as the keyway. Now due to the presence of this keyway on the shaft, there is a possibility of the stress concentration. This is the original shaft with the keyway. Now to reduce the stress concentration at this vicinity, due to the provision of keyway, we can drill additional holes. We can drill additional holes on the shaft. Now the keyway is a discontinuity and results in stress concentration at the corners of the keyway and reduces the torsional shear strength of the shaft, means torque carrying capacity. Due to the presence of keyway, this keyway causes the stress concentration first thing, and second, it reduces the torque carrying capacity of the shaft. So to reduce this stress concentration on the shaft, we can provide additional drillings of holes, giving fillet radius at the inner corners of the keyway, and there is another method of drilling two symmetrical holes on the sideways of the keyway. Here we have drilled two similar holes on the sideways of the keyway. This is the keyway. On the sideways of the keyway, we have drilled two holes. This will not affect anything, but it will reduce the stress concentration. These holes press the force flow lines and minimize their bending in the vicinity of the keyway. When there is a sharp bending of force lines in the vicinity of the corner, there is a possibility of the stress concentration. Now this is the method of stress concentration in the shafts. First we have seen when the component is subjected to the tensile force, means member in tension. Second, we have seen the member in bending. Third, we have seen for the transmission shaft. And fourth one is the reduction of stress concentration. Reduction of stress concentration in threaded members. When a threaded member is present, how we can reduce the stress concentration in the threaded members? Look at this. Now this is the threaded member. This is a threaded member, and this is the flow line of a force. This is the force flow line. Due to the presence of these threads, there is a chances of stress concentration when it enters from the shank side to the threaded side. This is the shank side, and when it enters into the threaded side, there is a chances of stress concentration at this point. Now we have to reduce the stress concentration. Now this thread will act as a discontinuity in the component. If this shaft or member is continuous like this, and when there will be no threads on the component, then there will be no chance of the stress concentration. But these threads on the component will act as a discontinuity in the component, which adds to the localization of the stress at this point. Look at this. There is a sharp bending of this force line, force streamline. So we have to reduce this stress concentration in the threaded member. So to reduce this stress concentration in the threaded member, the first method is provision of undercut before this threaded portion. A small undercut is taken between the shank. This portion is known as the shank. You know that. This portion is known as the shank, and this portion is known as the threaded portion. A small undercut is taken between the shank and the threaded portion of the component, and a fillet radius is provided for this undercut. This is the fillet radius. A fillet radius is provided for this undercut. This is the first method, how we can reduce the stress concentration in the threaded member. Now second method is, this reduces bending of the force lines. I have already told you, this reduces the bending of the force line and consequently reduces the stress concentration. And second method is an ideal method to reduce stress concentration is where the shank diameter is reduced. This is the shank diameter. Look at this shank diameter. Here is the original shank diameter, and here is the reduction in shank diameter. Now where the shank diameter is reduced and made equal to the core diameter of the thread. It is made equal to the core diameter of the thread. Now this is the core diameter. Now shank and core diameter of the thread has been made equal, due to which the force lines is almost straight and there is no stress concentration. Look at this force line. This is the force line. The force line is straight. In this case, there is a bending of force lines. Again, we have provided the undercut. Now this force line do not have sharp bending, and in this case the force line is straight. So there is another method how we can reduce the stress concentration in the threaded member. First way, providing the undercut in the threaded member. Second one is the reduction in the shank diameter. So today we have seen what is meant by the stress concentration, how stress concentration get caused, what is the concept of stress concentration, what are the different causes of stress concentration. The different causes of stress concentration that we have seen are the variation in the properties of the materials due to the uneven application of load, abrupt changes in the section, discontinuities in the component, machining scratches present on the component. We have seen the methods of reduction of stress concentration. Again, keep in mind, we can't reduce the 100% stress concentration, but we can reduce the intensity of the stress concentration. We can reduce the localization of the stresses at a particular point. So first method is providing additional notches and holes in a tension member. When the members are subjected to the tensile load or tensile stress, we can provide the additional notches and holes in the tension member. When the member is subjected to the bending, we can provide a fillet radius, undercutting and additional notches. When the member is subjected to the bending. When the member is a shaft, when there is a transmission shaft, and when there is a possibility of the stress concentration due to the presence of keyway, we can provide additional holes aside of keyway so that it can reduces the stress concentration. Fourth member is the reduction in stress concentration in the threaded members. How we can reduce the stress concentration in the threaded members? By providing a undercut and by making a shank diameter equal to the core diameter of the thread. In this way we can reduce the concentration of the stress, and these are the methods of reduction of the stress concentration. I hope you have understood the concept of stress concentration, what are the causes of stress concentration, and how we can reduce the stress concentration. Thank you.